Today we shall discuss some problems from the chapter in reference by division of amplitude. The first question is, in a wedge-shaped film, the distance between the successive fringes is measured to be 1.25 millimeter. The angle of the wedge is 40 seconds. Calculate the wavelength of the light used. That is a question. So it's in a wedge-shaped film, the distance between the successive fringes, that is beta, isn't it? Beta is equal to 1.25 millimeters. 25 millimeters. And the angle of the wedge is given, that is equal to 40 seconds. Theta is equal to 40 seconds. Okay. Now the question is, calculate the wavelength of the light used, that is lambda. So what is the equation for lambda? Lambda is equal to, or you can say beta is equal to lambda by 2 mu theta, isn't it? Lambda by 2 mu theta. Here, see, beta is given directly and mu is also given. It is given that mu is equal to 1.4. The value of mu is also given, that is equal to 1.4. Okay, so mu is there and theta. Theta is 40 seconds. 40 seconds means how many degrees? That is 40 divided by these seconds. Okay, so that is divided by 60 into 60, isn't it? So that much degrees. So this is in equal to, so that is again in degrees. Remember, in this case for the wedge-shaped films, the angle is taken in radians. Okay, because that is the opposite side by adjacent side. Okay, the tan theta we have taken and that value will be radians. So 40 seconds means 40 by 60 into 60 degrees. Okay, and that is equal to 40 by 60 into 60 into pi by 180 radians. Okay, pi by 180 radians. So this should be done and we have to convert the unit into radians. Okay, so this is the main thing to be remembered, and the value that is obtained is theta is, okay, the value is 0.194. It is equal to 0.194 into 10 to the power of minus 3 radians. Minus 3 radians. So this is the value of theta. Okay. Now you can write lambda is equal to 2 mu theta into beta. Okay. And that is equal to 2 into 1.4 into theta is 0.194 into 10 raised to minus 3 into beta is 1.25 millimeter. That is 1.25 into 10 raised to minus 3. Okay. So this is the value that is obtained is 6790 into 10 to the power of minus 10 meters. Okay. So 6790 Armstrong unit. So that is the value of lambda obtained. So remember, the theta should be converted into radians. That is the main important point to be remembered. So here there is if you have this value in these seconds, okay, if the minutes, then divided by 60, that you will get the degree. If it is in seconds, divided by 60 into 60, that you will convert that into degrees, then convert that into radians. Okay, so this is the value obtained. Now second one, is the thickness of a wedge-shaped square cellophane film cellophane film. Refractive index is given, that is mu is equal to 1.5. At two ends is T1 and T2 respectively. The thickness of a cellophane film. Like this. So this is the shape of a cellophane film. Cellophane film. Okay. Now the thickness are taken as T1 and T2. This is T1 and this is T2. Okay. Now, if the number of fringes seen on the film by light of wavelength 6000 Angstrom unit is 10. Find the value of T2 minus T1. Okay. Question once again. The thickness of a wedge-shaped square cellophane film of mu is equal to 1.5. The thickness is T1 and T2 respectively at the two ends, T1 and T2 respectively. And if the number of fringes seen on the film by light of wavelength 6000 Angstrom is 10, then find the value of T2 minus T1. Okay, so this is okay. So from here, this is the line parallel to the base. Okay, so this distance is T2 minus T1, isn't it? Now this one is illuminated with a light of wavelength 6000 Angstrom unit. Lambda is equal to 6000 Angstrom unit. Okay, and the mu is given. Mu is equal to 1.5. Okay, so it is illuminated by light of wavelength 6000. So the question is, if the number of fringes seen on the film by the light of wavelength is 10, that is number of fringes. Suppose this distance is taken as x, that is from here to here. So this angle is theta. The thickness will be increasing gradually from this end to this end. Okay. So the number of fringes seen for this total length is 10. Okay. Now see what is then beta. Beta equal to, so you can say the value, that is, sorry, not beta, that is, okay, here this is equal to theta. Okay, so the number of fringes obtained is equal to 10. Sorry. Obtained is equal to 10. Okay. Now, the question is, then you have to find the value T2 minus T1. Okay. Now, in this case, see, what is beta? It is number of fringes is 10. So, beta will be equal to 10 fringes will be obtained for a distance of x. Okay. X we don't know. So, this beta value will be equal to x by 10, isn't it? Beta is the width of one fringe. For a distance x, 10 number of fringes are there. So, the value of beta is equal to x by 10. Okay. Now, what is theta? Theta is equal to, from this figure, you have T2 minus T1 divided by x. That is equal to tan theta, isn't it? Tan theta is equal to opposite side by adjacent side. And if theta is small, you can say theta is equal to T2 minus T1 divided by x. Okay. Now, what we require is T2 minus T1. Okay. Now, we can write the equation for beta. That is equal to, beta is equal to lambda by 2 mu into theta. Isn't it? And this is equal to lambda by 2 mu into, what is theta? Theta is equal to T2 minus T1 by x, isn't it? Mu into T2 minus T1 by x. So that x goes to the numerator. It is a lambda into x by 2 mu into T2 minus T1. Okay. Now you have an equation beta equal to x by 10, isn't it? You can put the value. So that is beta is equal to x by 10. So x by 10 is equal to lambda x by 2 mu into T2 minus T1. Okay. X cancels and this gives, you have, what will be the value? X cancels. What we require is a T2 minus T1. So T2 minus T1 is equal to lambda into 10. Okay, 10 lambda divided by 2 mu, isn't it? 10 lambda divided by 2 mu. Okay, and you can put the value 10 into lambda is given 6000 into 10 raised to minus 10. Then divided by 2 into mu is given as 1.5. Okay, so when you are putting the values, the answer will be 2 into 10 raised to minus 6. Minus 6 meters. Okay, so that is the value obtained. Okay. 2 into 10 raised to minus 6 meters. So next question is, a glass wedge of angle 0.01 radian. Again, a wedge shaped one. A glass wedge of angle 0.01 radian is illuminated by monochromatic light of wavelength 6000 Armstrong unit that is falling normally on it. At what distance from the edge of the wedge will the 10th fringe will be observed by reflected light? Okay, so that is the question. A glass wedge of angle, I can draw it. Angle is given theta, and theta is equal to 0.01 radians. 0.01 radians. Okay. Now the light that is used, lambda is equal to 6000 Armstrong unit again. Okay. Now the question is, at what distance from the edge of the wedge will the 10th fringe will be observed by reflected light? Okay, suppose the 10th fringe is observed at this particular point. Okay, so at this particular point, suppose the thickness is equal to T. Okay, now this distance is taken as x. Okay, now what is theta? Theta is equal to T by x, isn't it? Theta is equal to T by x, or T is equal to theta into x. Okay. Now, what is the equation for the interference? That is 2 mu t cos r is equal to n lambda is the equation for a dark fringe. And the question is, where will the 10th fringe be observed? Okay, so we can take this one. So the 10th fringe, dark fringe, is obtained at 2 mu t cos r equal to n lambda. Okay, now what is cos r? If you are taking normal incidence, cos r is equal to 1, and mu is equal to 1 if we are taking air film. So in this case, you can write it as 2 into mu is equal to 1. You can take mu is equal to 1. It is not given. Mu is equal to 1 for air. So 2 into cos r is equal to 1. Okay, cos r is equal to 1 for normal incidence. So 2 into t equal to n lambda. Okay, and what is t? T is equal to theta into x. So you can write it as 2 into theta into x equal to L lambda. So what is x? X is the distance. Okay. So x is the distance. So x is equal to n lambda divided by 2 theta. Okay. X is equal to n lambda by 2 theta. You can put the values there. N is equal to, the question is that where do you get the 10th fringe, that is n is equal to 10. Okay, so you can 10 into lambda is 6000 angstrom into 10 raised to minus 10 upon 2 into theta. 2 into theta is directly given in radians, so 2 into 0.01. Okay. So this is that will give you the value of x, and the x is equal to, this obtain as 3 into 10 raised to minus 3 meters or 3 millimeters. Okay, so that is the value obtained. Now, next question is a thin equiconvex lens. Equiconvex means both sides are symmetric. Okay, equiconvex lens of focal length 4 meter and refractive index 1.5 rest on and in contact with an optical flat. Okay, and using light of wavelength 5460 angstrom, Newton's rings are viewed normally by reflection. What is the diameter of fifth bright fringe? That is the question. So here, read it again. There is a thin equiconvex lens of focal length 4 meter and a refractive index 1.5 rest on and in contact with an optical flat. Optical flat means it's an optically flat glass plate, that's all. And using a light of wavelength 5460 angstrom unit, Newton's rings are viewed normally by reflection. What is the diameter of the fifth bright fringe? Okay. So here, thing is that you have an optically flat glass plate. Okay. On which there is a convex lens. Okay. So there is an equiconvex lens. And the focal length is given, that is equal to 4 meters. F is equal to 4 meters. And light of wavelength lambda is equal to 5640 angstrom unit. 5640 angstrom unit falls on that one normally. And you will get the Newton's rings. Okay, already told you that the planar convex lens is not a necessity. Even though you are using a biconvex lens, still you will get the Newton's rings. Okay. Now 5640 angstrom unit is the wavelength used. Now the question is, what is the diameter of the fifth bright fringe? Okay. And refractive index is also given, mu is equal to 1.5. And for the bright fringe, the diameter of the bright fringe, what is the equation? So there is Bn for a bright fringe. diameter of the nth bright fringe is given by 2 into square root of n minus half into r into lambda. Okay, so this is the equation. See, for the dark fringe, we have seen already its derivation. Dark fringe, the radius is given by square root of r into n into lambda. This is the equation we have obtained. Okay, where n is equal to 1, you have the first ring and so on. Okay, and see, for the diameter of the nth dark fringe is given by twice the radius, that is 2 into square root of r into n into lambda. N into lambda. Okay. Now, this is for the dark fringe. Okay, dark fringe. And for the bright fringe, the equation is Rn is equal to square root of r into n minus half into lambda. Okay, r into n minus half into lambda. This is the equation. Okay. So for the first bright ring, r into 1 minus half, that is equal to half lambda. Okay. Because half lambda, that is the path difference that is required. And 2 times that one will be for the constructive inference. Okay. Leave it. So this is Rn into square, that is equal to square root of r into n minus half into lambda. So same thing, this is the diameter 2 into square root of n minus half into r into lambda. Okay. Now lambda is there, it is given, and n is the fifth bright fringe, isn't it? N is equal to 5. That is given us n is equal to 5. Okay, fifth bright fringe. Now what is required is r. Okay, the radius of curvature of the lens should be needed, and all that is given is the focal length f is equal to 4 meters. Okay, and the refractive index is given. Then here we have to find the radius r, we have to use the lens maker's formula. Okay, the equation for the convex lens. So that is equal to 1 by f is equal to mu minus 1 into 1 by r1 plus 1 by r2, isn't it? So if you are not using the sign convention, then it will be minus 1 by r1 minus 1 by r2. Okay, so 1 by r1 minus 1 by r2, this is the first surface and this is the second surface. Okay, so this is a part of a big circle. Okay, this one, and the radius, this is the radius. Okay, and this one r2 is like this. So the radius will be in the opposite direction, isn't it? When you are measuring it, it is in the opposite direction. Okay, so two circles are towards the opposite sides. Okay, so using the sign convention, this value will be r2 will be negative. If you are taking r1 positive, r2 will be negative, because r1 is along this direction, r2 is along this direction. Okay, so anyway, then using the sign convention, this will again become r2 will become negative, and therefore minus of minus, this one will become positive. Okay, so mu minus 1 into 1 by r1 plus 1 by r2, that is the equation for 1 by f. This is called the lens maker's formula, isn't it? So, and it is given that the lens is a thin equiconvex lens. Equiconvex lens means the two radii are the same. Okay, so you can simply write this 1 by r plus 1 by r. So this is 1 by f is equal to mu minus 1 into, both are same, so you can write it as 2 divided by r, isn't it? Because 2 into 1 by r, 2 by r. So what is r? R is equal to 2 into mu minus 1 into f, isn't it? 2 into mu minus 1 into f. So mu is 1.5, f is equal to 4 meter. Okay. So this is 2 into 0.5 into F is equal to 4, isn't it? F is equal to 4. So you will get the value of R is equal to, that is equal to 4 itself. Okay. So the same as that of F. The R will be equal to 4. Okay, that is 4 meters. Now putting the value here. Now all these values are there. N is 5. R is now known, that is 4 meter, and lambda is equal to 5640 Armstrong unit. Putting those values, you will get the answer for, or the value of the Dn, that is D5, diameter of the fifth bright fringe, that is equal to 2 into square root of 5 minus r into 4 into the lambda 5640. Minus 10. Okay. So the answer that is given is obtained is 6.2 millimeters. So that will be 6.2 millimeters will be the diameter of the fifth bright fringe. Okay. So we will stop here and we shall continue in the next class. Okay.